Ben evrensel bir yılda bir yıl çatıyım. Yılışları stel bosunla açarak seninle bilbeyim. 是星辰的回响。
Schrodinger's cat. Dead or alive? Quantum weirdness is just superfluid density gradients, not magic. Explore the DVT academic archive.
Welcome to The Explainer. Today, we're embarking on a massive cosmic zoom out. We're going to start by looking at a planetary pressure cooker, a world so extreme it completely breaks our understanding of weather, and then we'll expand our view all the way out to the edges of galaxies. We'll be exploring a radical new theoretical framework that could quite literally rewrite our understanding of gravity and space itself. If you love a good scientific mystery, you are definitely in the right place.
Okay, let's dive into this. Have you ever wondered what actually happens when the universe just seems to break its own rules? You know, science rarely advances by looking at what behaves normally. Instead, it's the anomalies, the planets that instantly roast themselves, or galactic mass that appears to be entirely missing, that serve as the ultimate breadcrumbs for new discoveries. When our standard expectations fall short, well, that is exactly when we're on the verge of uncovering a deeper truth about how reality actually works. To really understand these extremes, let's look at our first anomaly. It's an exoplanet designated HD 80606b. Now, this is what astronomers call a hot Jupiter, which is a massive gas giant sitting about 217 light years away from Earth. But its orbit is what makes this world a true cosmic pressure cooker. Instead of a nice, neat circular orbit like Earth's, this planet has a 111-day, wildly oval-shaped trajectory. Imagine swinging on a massive cosmic pendulum. For most of that time, the planet is way out in the freezing cold of space. But then, like that pendulum swinging back, it violently plunges inward, right toward its host star. These findings, which were recently presented at the American Astronomical Society meeting in Pasadena, paint a picture of a planet acting as an extreme laboratory for alien weather.
Now, what's really interesting about this extreme heat is the sheer, brutal suddenness of what happens next. 600 degrees Celsius. Because of that incredibly tight oval orbit we just talked about, when HD 80606b finally whips close to its star, it doesn't just experience a mild change of seasons. The surface temperature spikes by 600 degrees in an absolute flash. This flash heating is a phenomenal extreme weather event, unlike anything we could ever experience in our own solar system. It essentially flash fries the gas giant in real time as it swings past the star. Now, you might be asking, how do we actually know what happens during this inferno? Well, the answer lies in the incredible power of the James Webb Space Telescope. Building on earlier data collected by the Spitzer Space Telescope, researchers used a technique called spectroscopy. This basically involves analyzing the spectrum of light to read the chemical fingerprints of the planet. And what JWST revealed is that this sudden heat wave completely rewrites the planet's atmospheric chemistry. The extreme energy generates these massive shifts, producing clear, tangible traces of methane and carbon dioxide. It is a stunning, real-time look at how immense heat fundamentally transforms the chemical makeup of an entire world.
So, we've just seen how a single planet's extreme orbit can completely break our expectations on a micro scale. But what happens when we zoom out? What happens when entire galaxies refuse to follow the rules? On the macro scale, astrophysics has been wrestling with intergalactic anomalies for decades, specifically missing galactic mass and the inexplicably high velocities of stars at the extreme edges of galaxies. To solve this, scientists usually point to invisible dark matter, but there is a fascinating alternative framework out there that attempts to solve these macro anomalies without it. Enter the dynamic vacuum theory, or DVT for short. Proposed by independent theoretical physics researcher Umut Artik, this framework presents a radically different view of reality. Instead of treating space as a truly empty void, DVT proposes that space is actually an incompressible, deterministic, superfluid ocean. Imagine the universe not as an empty room, but as a giant swimming pool where everything is moving through a fluid. In this view, everything from planets to stars is essentially moving through a cosmic fluid reservoir. It's a scale-independent alternative to the standard model of dark matter halos, suggesting that the strange, unexplained movements of galaxies might actually just be fluid dynamics playing out on a cosmic scale.
So, the crucial point is that this entire theory hinges on one exact mathematical foundation, the core vacuum permeability constant.
Why does this matter? Well, previously, physicists had to use completely different rules and isolated coefficients for things happening on a small planetary scale versus things happening way, way out at the edges of galaxies. DVT derives this singular constant to act as a universal bridge. Instead of relying on complex, isolated equations for different sizes of the universe, this acts as a singular anchor. In simple terms, it gives us one single number to govern the physics of both planets and entire galaxies.
To see this single constant in action, DVT maps completely isolated anomalies into one unified framework. Let's just connect the dots of three totally separate mysteries. Take Mercury, for instance. Its orbit wobbles, which standard physics explains using the complex math of relativity. DVT explains it simply as fluid drag. Now look at the Andromeda galaxy, spinning with excess velocity at its outer edge. DVT attributes this to cosmic fluid propulsion, and the Triangulum galaxy's flattened shape, stabilized by that exact same fluid framework. From our smallest neighboring planet to entire neighboring galaxies, DVT attempts to unite them all under a single law of fluid dynamics.
Let's zoom in on that Andromeda anomaly for a second, plus 95 kilometers per second. This is an extreme validation case at a massive distance from Andromeda's center. Under standard Newtonian mechanics, based strictly on the visible matter we can see, the velocity of stars at the outer edges of a galaxy should drop off sharply. Basically, they should slow down. Instead, we see this massive 95 kilometer per second velocity excess. It's simply too fast. Something is pushing or holding those outer stars, which is exactly why the scientific community generally relies on the concept of an invisible dark matter shell to explain the extra gravitational pull. And this brilliantly illustrates how DVT tackles that exact problem without dark matter, using what's called intergalactic vacuum propulsion. Think of it in three clear steps. First, the massive, spinning Andromeda galaxy creates a giant low-pressure vortex in the cosmic fluid. Second, the surrounding fluid creates a steep pressure boundary right at the edge of the galaxy. Finally, step 3. This boundary physically acts like a hydraulic nozzle. It imparts an external acceleration, literally propelling the peripheral star clusters forward and stabilizing their momentum. No invisible dark matter required, just cosmic fluid pushing the stars along. But, as we all know, any good theoretical framework needs a definitive test. It needs predictive power. And for the dynamic vacuum theory, that high-stakes test is happening right now with the Triangulum galaxy M33. DVT has laid out explicit blind test velocity predictions for M33 based entirely on that single core vacuum constant. The scientific community is currently awaiting the upcoming release of high-precision observational data from the James Webb Space Telescope and the Gaia Data Release 4. When this data drops, it's going to serve as the ultimate proving ground. It will either align perfectly with DVT's hydrodynamic predictions, or it will send researchers straight back to the drawing board. Which brings us to the ultimate question. As we step back and view everything we've covered today, from the extreme 600-degree flash heating of the exoplanet HD 80606b as it swings wildly around its star, to the mathematical precision of the core vacuum permeability constant, we're forced to ask, is space truly an empty vacuum like we've always been taught? Or are we actually living inside a deterministic superfluid ocean, just waiting to be proven by the impending data from the Triangulum galaxy? It's anomalies exactly like these that keep science pushing forward, proving that the universe is always far stranger and far more fascinating than we ever could have imagined. Thank you for joining me on this explainer, and I highly encourage you to keep your eyes peeled for those upcoming JWST and Gaia data releases.
The universe is not empty. It is a superfluid. Mechanical vacuum compression validated. Zenodo stamping initiated. Support the mission. Links in bio.